So this is 5.6, number 19 from substitution. I call U sub. So we look at this and we have no clue how to find an antiderivative just because there's no quotient rule for integration. There's no product rule. There's none of that. So we have to try something. This is like the equivalent of our chain rule in derivatives. You're looking for the function, usually, not always, usually the function that's inside of another function. And if you look closely, you will notice that this is a good candidate right there because it's inside of another function. So a lot of this is trial and error, and then over time, you're going to get better and better at doing this. So if we choose that to be u, so we're going to let u equal 1 minus 4x cubed. So we're defining a new variable u, and it's 1 minus 4x cubed. You choose that. And based on that, we're going to rewrite this integral. So if I were to just do that, this would become the integral of square root of u, because I chose this to be u. So it's already looking a lot prettier than the previous one, but we still have this to deal with. That has an x and that has an x. And so what do? So the next step always is find the derivative of that. So it's going to be du dx because our function is u and our variable is x. So it's du dx in differential form. The derivative of 1 is 0. And then I bring the 3 in front, giving me 12, and I decrease the power by 1. And then I'm going to move the dx to the right side, multiply by that. So I'm going to get this differential form. And so we want to get rid of that. I'm going to show you two different ways to do that. One is to say, hey, I wish I had a negative 12x squared dx. I don't. It's almost there. If that were negative 12, all of this could be replaced by du. So I say to myself, self, how do I get a negative 12 here? I'd have to multiply by negative 6, but I can't just randomly add a negative 6 there, but I can multiply by 1, which is negative 6 over negative 6. I'm allowed to do that. And if I do that, watch what happens. The top becomes negative 12x squared. Beautifully, right? And then I can use a property where I'm allowed to move a constant out in front so that negative 6 can come out in front, and I get that. Now something wonderful happens. All of this, if you look, is just du. So all that gets replaced with du, and I have a negative 1/6 in front. That is so much prettier. All my x's have been changed to u's, and now I can do this. So I'm going to rewrite this. This is going to be negative 1/2 du. The reason, the square root is the same as a 1/2 power. If I move it to the top, it becomes negative 1/2. And now I'm home free. I know how to do this. So I've converted something that was complicated and weird looking into a nice simple integration or antiderivative. And so the negative 1/6 gets copied. I add 1 to the exponent. Negative 1/2 plus 1 is positive 1/2, but then you divide by that using the power rule, and you need a plus c. And how do I get rid of that? I multiply by the reciprocal, which is 2 over 1. And what we see, the 2 and the 6 cancel, leaving a 3. So I have a negative 1/3 square root u plus c. I'm almost done. Almost. So the only problem is I started with x's. So my final answer should have x's in it. So my final step is to replace u with its equivalent 1 minus 4x cubed. So we get negative 1/3 square root of 1 minus 4x cubed plus c, and that is my final answer.